Hello students. Today we'll start with a new lecture on classification of elements and periodicity in properties. To start with, we will quote Glenn T. Seaborg, who said, quote, "The periodic table is arguably the most important concept in chemistry, both in principle and in practice. It is everyday support for students. It suggests new avenues of research to professionals, and it provides a succinct organization of whole chemistry. It is a remarkable demonstration of the fact that the chemical elements are not a random cluster of entities, but instead displace trends and lie together in families. An awareness of the periodic table is essential to anyone who wishes to disentangle the world and see how it is built up from the fundamental building blocks of chemistry, the chemical elements." Unquote. So, we will have detailed discussions about why do we need to classify elements, genesis of periodic classification, modern periodic law, and the present form of periodic table. As you know, this is a part of chemistry for class 11 as per the NCERT syllabus rationalized for the year 2023-24. All the points discussed in this lecture are very important. Please listen to the lecture carefully and note down the points. So, I welcome you once again. First question is, why do we need to classify elements? In this unit, we will study the historical development of periodic table as it stands today, and the modern periodic law. We will also learn how the periodic classification follows a logical consequence of electronic configuration of atoms. Finally, we shall examine some of the periodic trends in physical and chemical properties of elements. First come first, why do we need to classify elements? We know by now that the elements are the basic units of all types of matter. In 1800, only 31 elements were known. By 1865, the number of identified elements had more than doubled to 63. At present, 114 elements are known. Of them, the recently discovered elements are man-made. Efforts to synthesize new elements are continuing. With such a large number of elements, it is very difficult to study individually the chemistry of all these elements and their innumerable compounds individually. To ease out this problem, scientists searched for a systematic way to organize their knowledge by classifying elements. Not only that, it would rationalize known chemical facts about elements, but even predict new ones for undertaking further study. Classification of elements into groups and development of periodic law and periodic tables are consequences of systematizing the knowledge gained by a number of scientists through their observations and experiments. Genesis of periodic classification. The German chemist Johann Dobryner in early 1800s was the first to consider the idea of trends among properties of elements. By 1829, he noted a similarity among the physical and chemical properties of several groups of three elements called triads. In each case, he noticed that middle element of each triads had an atomic weight about halfway between atomic weights of the other two. Please see the table shown on your screen. The properties of middle elements were in between those of the other two members. Since Dobriener's relationship, referred to as law of triads, seemed to work only for few elements, it was dismissed as coincidence. The next reported attempt to classify element was made by French geologist A.E.B. de Chancourtois in 1862. He arranged the then known elements in order of increasing atomic weights and made a cylindrical table of elements to display the periodic recurrence of properties. This also did not attract much attention. The English chemist John Alexander Newlands in the year 1865 propounded the law of octaves. The table on your screen shows the law of octaves. It is called Newland's law of octaves. Newlands arranged the elements in increasing order of their atomic weights and noted that every 8 element had properties similar to first element. So you can see he has arranged elements in the order of increasing atomic weight. The table shows lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. The relationship was just like every 8 note that resembles the first in octaves of music. Newland's law of octaves seemed to be true for only elements up to calcium. Although his idea was not widely accepted at that time, he for his work was later awarded Davy Medal in the year 1887 by the Royal Society of London. Luther-Mayer's atomic volume curve. The periodic law, as we know it today, owes its development to the Russian chemist Dmitry Mendeleev, who lived between 1834 to 1907, and the German chemist Luther Mayer, who lived between 1830 to 1895. Working independently, both the chemists in the year 1869 proposed that on arranging elements in the increasing order of their atomic weights, similarities appear in physical and chemical properties at regular interval. Luther Mayer plotted the physical properties such as atomic volume, melting point, and boiling point against atomic weight and obtained a periodically repeated pattern. Unlike Newland's, Luther-Meyer observed a change in length of that repeating pattern. By 1868, Luther-Meyer had developed a table of the elements that closely resembles the modern periodic table. However, his work was not published until after the work of Dmitry Mendeleev, the scientist who is generally credited with development of modern periodic table. Thus, Dmitry Mendeleev, who published the paper, is generally credited with the development of the modern periodic table. Chemist Dobereiner initiated the study of periodic relationship, but it was Mendeleev who was responsible for publishing the periodic law for the first time. This law states that the properties of elements are a periodic function of their atomic weights. Mendeleev arranged these elements in horizontal rows and vertical columns of a table in order of their increasing atomic weights in such a way that elements with similar properties occupied the same vertical column or group. Mendeleev's system of classifying elements was more elaborate than Luther-Meyer's. So, he said that if elements are arranged in their order of increasing atomic weights after regular interval, elements with similar properties are repeated. The table is divided into 9 vertical columns and 7 horizontal rows as shown in the table in the next slide. So, in order to study this Mendeleev's periodic law, which was published in 1869, please refer to the table shown in the next slide. You will observe that he placed elements having the similar nature in the same vertical column or group with respect to the atomic weight. Please underline the word atomic weight. At some places, the order of atomic weight was changed in order to justify the physical and chemical nature of elements. Some places were left vacant. Keeping his primary aim of arranging the elements of similar properties in the same group, he proposed that some of the elements were still undiscovered and therefore he left several groups in gaps. He made several gaps in the table. For example, both gallium and germanium were known at the time of Mendeleev published his periodic table. He left the gap under aluminum and a gap under silicon as shown in the table above. These gaps are called Ica aluminum and Ica silicon. See, Ica aluminum and Ica silicon. So this is that is the prediction. Ica aluminum, which he predicted with atomic weight, density, melting point, formula oxide, and formula of chloride, which was undiscovered in the year 1869. Later on, gallium was found and it occupied this place. Mendeleev predicted not only the existence of gallium and germanium but also prescribed some of their general physical properties. This is the Eka aluminum is the prediction. Similarly, Eka silicon is the prediction. These elements, that is gallium and germanium, were found later. Some of the properties predicted by Mendeleev for these elements and those found experimentally are shown in this table. Please go through each and every property shown in columns and rows. The boldness of Mendeleev's quantitatively predictions and their eventual success made him and his periodic table famous. Mendeleev's periodic table was published in the year 1905 and it is shown in the next slide. Demerits of Mendeleev's periodic table. Though Mendeleev said properties of elements are periodic function of their atomic weights, but there were certain demerits of Mendeleev's periodic table, and these are: first one, position of hydrogen was anomalous. It resembles group first elements like alkali metals and group 7 elements, that is halogens, but it was placed in group first only. The next anomaly was the atomic mass of cobalt was 58.9, which is larger than the atomic mass of nickel, that is 58.6. But cobalt was placed before nickel. Similarly, isotopes were not given separate place, though Mendeleev's classification is based on atomic masses. Mendeleev could not explain the cause of periodicity in elements. Lanthanides and actinides were not included in his table. So, the table published by Mendeleev in the year 1869 is shown on the screen. So, it has columns and rows. This table is divided into 9 vertical columns and 7 horizontal rows. The elements are placed in the same vertical which are having similar nature with respect to the atomic weight. At some places, the order of atomic weight was changed in order to justify the physical and chemical nature of elements. Some places were left vacant for new elements which were not discovered in the year 1869. So please pause this video and note down all the contents of this table. Modern periodic law and present form of table. We must bear in mind that when Mendeleev developed his periodic table, chemists knew nothing about the internal structure of atom. That is the most important point. However, the beginning of 20th century witnessed profound elements in theories about subatomic particles. In the year 1913, the English physicist Henry Moseley observed regularities in characteristic X-ray spectra of elements. A plot of square root of nu, where nu is frequency of X-rays emitted against atomic number Z gave a straight line and not a plot of square root of nu versus atomic mass. So he plotted square root of nu versus atomic number, which gave a straight line instead of a plot of square root of nu versus atomic mass. He thereby showed that the atomic number is more fundamental property of an element than its mass. Mendel's periodic law was therefore accordingly modified. So instead of atomic mass, he used the atomic number Z. Thus, this periodic law was also changed, which stated the modern periodic law stated that the physical and chemical properties of elements are periodic function of numbers, periodic function of their atomic numbers. The periodic law revealed analogies among the 94 naturally occurring elements. Neodymium and plutonium like actinium and protoactinium are also found in an ore of uranium. It stimulated renewed interest in inorganic chemistry and has carried into the present with creation of artificially produced short-lived elements. The atomic number is equal to the nuclear charge, that is the number of protons or number of electrons in a neutral atom. It is then easy to visualize the significance of quantum numbers and electronic configuration in periodicity of elements. Thus, it is now recognized that periodic law is essentially the consequence of periodic variations in electronic configurations, which indeed determine the physical and chemical properties of elements and their compounds. Hence, please note that the periodic law is essentially the consequence of the periodic variations in electronic configurations, which indeed determine the physical and chemical properties of elements and their compounds. Numerous forms of periodic table have been devised from time to time. Some forms emphasize chemical reactions and valence, whereas the others stress the electronic configuration of elements. Please see the figure shown on screen. This depicts the long form of periodic table of the elements with their atomic numbers and ground state outer electronic configuration. The groups are numbered 1 to 18 in accordance with the 1984 IUPAC recommendations. This notation replaces the old numbering scheme of 1A to 7A, 8, 1B to 7B and 0 for the elements. Please pause this video and note down and copy and write this table. In this long form of periodic table, there are 7 horizontal rows called periods and 18 vertical columns called groups. The period number corresponding to the highest principal quantum number n of the element in the period. Thus, the period number corresponds to the highest principal quantum number n of the elements in the period. In this form, the periodic table 14 elements of both 6th and 7th period, that is lanthanoids and actinoids respectively, are placed in a separate panels at the bottom. So these are lanthanoids and actinoids. Thus, summarizing, a modern version of the so-called long form of periodic table of elements shown in the previous slide is most convenient and widely used. There are 7 horizontal rows which Mendeleev's called series. They are also called periods, and 18 vertical columns are called groups. Elements having same outer electronic configurations in their atoms are arranged in vertical columns referred to as groups, or they are also called families. According to recommendations of International Union of Pure and Applied Chemistry, that is IUPAC, these groups are numbered from 1 to 18, replacing the older notation of groups 1A to 7A, 8, and 1B to 7B and 0. There are altogether 7 periods. The period number corresponds to the highest principal quantum number n of the elements in the period. The first period contains 2 elements. The subsequent periods contain 8, 8, 18, 18 and 32 elements respectively. 7th period is incomplete and, like the 6th period, would have a theoretical maximum on the basis of quantum numbers of 32 elements. In this form, the periodic table 14 elements of both 6th and 7th periods, lanthanoids and actinoids respectively, are placed in separate panels at the bottom. Please note that Glenn T. Seabock's work in the middle of 20th century, starting with the discovery of plutonium in 1940, followed by those of transuranium elements from 94 to 102, led to the configuration of the periodic table, placing the actinoids below the lanthanoids. In the year 1951, Seaborg was awarded Nobel Prize in Chemistry for his work. Element 106 has been named Seaborgium, that is Sg, symbol Sg, in his honor. In the long form of periodic table, there are 7 horizontal rows called periods and 18 vertical columns called groups. 18 columns are not shown on the table displayed depicted on the screen. The period number corresponds to the highest principal quantum number small n of the elements in the period. Please see the table on screen. The first column shows the period. That is, you know that there are 7 periods. Period 1st to 7th are given in column number 1. The period number corresponding to the highest principal quantum number n, that is the value of n, is also shown in column number 2, that is 1, 2, 3, 4, 5, 6 and 7, and the corresponding orbital filled up is given in column number 3. The number of elements in the period, that is 2, 8, 8, 18, 18 and 32, are given in column number 4. A brief description about the atomic numbers from 2 is given in column number 5 and 6. That is, it starts from hydrogen 1 to helium 2 in the first period. Similarly, for other periods, up to 118 elements are given in the 7th column. So, a brief about the periodicity is also given in the remarks column. In the first period, the period is very short. For the second, short period. For the third, short period, whereas fourth and fifth have long periods. Sixth and seventh period have very long periods. So this is for remembering in brief. Now we will answer some of the multiple choice questions quickly. Which of the following element has been discovered recently and is radioactive? So 4 options are given. Option A, indium. Option B, livermorium. Option C, rhodium. Option D, technetium. So you have to remember and mark livermorium as the correct answer. Next question. According to law of triads, you have to identify the correct answer. 4 options are given. Option A, the properties of the middle element were in between those of the other 2 members. Option B, 3 elements arranged according to increasing weight have similar properties. Option C, the elements can be grouped in the group of 6 elements. Option D, every third element resembles the first period in periodic table. Please pause this video and mark your answer and compare with my answer, which is given here. The correct answer is the properties of middle element were in between those of the other 2 members. Next question. Law of octaves stated. So 4 answers are given, 4 options are given, and you have to mark the correct answer. Option A, every 8 element has properties similar to the first element. Every third element has properties similar to the first element. Option C, the properties of middle element were in between the properties of the other 2 members. Option D, the properties of elements were repeated after regular intervals of 3, 4 or 18 elements. So you have to remember the law of octaves and mark your answer. Please pause the video and mark the correct answer, and I will give the correct answer. The law of octaves states that when lighter elements are arranged in order of their increasing atomic weights, the properties of every 8th element were similar to those of the first one. Please note, the properties of every 8th element were similar to those of the first one. This answer is given as option A. So please mark it. Next question. The first periodic law stated by Mendeleev was, four options are given and you have to read all and mark the correct answer. There is no correlation in properties and atomic weights of elements. Option B, the properties of elements are periodic function of their atomic numbers. Option C is the properties of elements are periodic function of their atomic weights. Option D is the properties of elements are a periodic function of their empirical formula. Please pause this video and apply your mind for some time and mark the correct answer. Meanwhile, I will give the correct answer. So you have to remember that the properties of elements are periodic function of their atomic weights as per the Mendeleev's law published in 1869. Next question. What were the main demerits of Mendeleev's periodic table? So four answers are given. You have to identify the correct answer. So there are more than one correct answers. So I will read all the four first and you have to identify the combination of these four answers. Hydrogen has been placed in group 1 though it resembles to group 7 as well. Number 2 is position of some elements are not justified. Point 3 is isotopes were not given separate places. Answer 4 is lanthanides and actinides were not included in the table. Please read the question and the answers therein and you have to identify the correct combination of these four answers. So option A is 1, 2 and 3 and option B is 1, 2, 3 and 4 and option C is 2 and 4 and option D is 1, 3 and 4. Please read the question and apply your mind and mark the correct answer. The correct answer is 1, 2, 3 and 4. So all the four are the demerits of Mendeleev's periodic table. Next question. In the long form of periodic table, elements are arranged in increasing order of A. Option A is atomic mass, option B is atomic number, option C is mass number, option D is metallic character. So you have to read the question once again and mark the correct choice, correct answer. Meanwhile, I will give the correct answer. So you have to remember that in the long form of periodic table, elements are arranged in the increasing order of atomic number. So option B is the correct answer. Next question. The period to which an element belongs to in the long form of periodic table represents option A atomic mass, option B atomic number, option C principal quantum number, option D azimuthal quantum number. Please pause the video, read the question as well as the options and mark the correct answer. I will give the explanation for the correct answer. N is the principal quantum number or number of shells. It represents the number of period to which an element belongs to. Hence, the correct answer is principal quantum number. Please mark the option C. Next question. Elements belonging to same group of table have option A same number of energy level, option B same number of valence electrons, option C same number of electrons, and option D is same ionization enthalpy. Please pause the video, read the question once again and mark your answer. I will give the correct answer, that is the same number of valence electrons. With this we come to the end of our first lecture of unit 3, that is in classification of elements and periodicity in properties. In the next lecture we will study about nomenclature of elements with atomic numbers greater than 100. We will also study electronic configurations of elements and periodic table, as well as electronic configurations and types of elements. Till then, goodbye.